Hello everyone. Today we will do a simple activity to show that the diagonal of a parallelogram divides it into two congruent triangles. For the same purpose, I have prepared a parallelogram, that is ABCD is a parallelogram. I have cut a parallelogram from a colored paper and I have joined the diagonal, named it as ABCD, and I have joined the diagonal, and you can see I have written points A over here and C also I have written 2 times, so that when I cut this triangle and I look for overlapping for the congruency, I can see which triangle, which angle particularly overlaps with the other triangle. So my parallelogram is ready. ABCD is a parallelogram, AC is the diagonal. Now I have to show that this triangle is congruent to this, that is triangle ABC is congruent to triangle CDA. For that purpose, I will cut this parallelogram along its diagonal, that is AC, and when I will cut this along its diagonal AC, you can see I will get two triangles, and now I have to look for their congruency, whether they are congruent or not. So for superimposition, for example, I have these two triangles, and if I try to put this point A on point A like this, I will see that these two triangles, they are not overlapping. That means in a parallelogram, it is not necessary that angle A will be equal to angle A. This happens, for example, in case of square, we can have a direct overlapping, and there you can see that there is a congruency in triangles. But in general, if we talk about a parallelogram, then we always talk about the alternate interior angles that we so get by drawing parallel lines. Since this line AD is parallel to BC, this angle that I am marking over here, that is this angle A, which is DAC, will be equal to BCA. So whenever I will try to overlap these to look for congruency, I have to turn it like this and I have to put it on the other triangle, and then I can see that there is 1-to-1 overlapping in both the triangles. So 1-to-1 overlapping means angle B corresponds to angle D, angle A of this triangle corresponds to angle C of the other triangle, and then we have angle C of this triangle corresponds to the angle A of another triangle. So this is how we can see that the congruency is there. And when we talk about this line segment as being equal in both the triangles as the common side, we always name it as AC is equal to CA. So AC will be equal to CA. So we can easily show the overlapping and show that the two triangles so formed are congruent to each other with 1-to-1 correspondence between points B and D, then angle A of this and angle C of the other triangle, and the angle C of this triangle and angle A of other triangle. So we have shown that the diagonal of a parallelogram divides a parallelogram into two congruent triangles. Thank you so much.